Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for a variant of jump game problem. Let's look at the problem description. We are given a zero indexed array of length n and we are initially positioned at the first index 0. And each element represents the maximum length we can jump from that position. For example, if element num of I represents the maximum length of forward jump from index I. And if you are at index num I, we can jump to any position num of I plus j, where j is from 0 to the value of that particular position num of I. And also I plus j is always less than n. We have to return the minimum number of jumps to reach the last element of that array. Okay, so it is guaranteed that we can reach num n minus 1 for all the inputs. Let's take a look at the example 1. Here we have nums array 2, 3, 1, 1, 4. So from index 0 we can jump 2 positions. From index 1 we can jump 3 positions, and index 2 1, and index 3 1, and index 4 4 positions. How many jumps we can do? From here we can make one jump to index 1. From there, based on this value, we can jump 3 maximum. So eventually we reach the last element. So totally 2 jumps. So that's why the output is 2. And the constraints are the number of elements in the array is at least 1 all the way up to 10,000. The value is ranging from 0 to 10,000. And also it is guaranteed that we can reach num of n minus 1. Let's look at the approach to solve this problem. So for this input, the approach 1 is we can do exhaustive search. Like we can try all possible path to the last element. So if we can represent the traversal as a tree. For example, this is an index of an element in the array. Okay, so this is the 0th index. From there we can jump 1 step or 2, and from here, from index position 1, we can jump 3 locations. Okay, and so similarly we can extend that tree based on the jump length. Okay, so at the end we get 1 2 3 4 paths to the last element in the array, but we have to return the minimal jump. So in this case, this is the shortest, only 2 jumps we can reach the last element 4. Okay, so whenever we reach the last element in this tree, we compare the total number of steps to reach the last element with the minimal jumps we have computed so far. So whichever is less, we updated the minimal jump variable, and after traversing the entire tree, finally we get the lowest value 2. That is one approach. This is time complexity is exponential. We can find the minimal number of jumps by traversing that array linearly. First we starting from index 0. Okay, and we maintain there are 3 variables. One is the jump count, which keeps track of the number of jumps we have to make, and another variable is the current maximum reach. That so what this variable does is, from any given index, how far we can jump, that information it keeps track. For example, in this case index is 3, so index is 1. So from here we can make the jump length is 3, so we can reach all the way up to this point. So that's why the current maximum reach is 4, and the last maximum reach is so far the previously computed longest maximum reach. Okay, So that it keeps track of the previously computed longest reach. So we updated this last maximum reach whenever the current index is equal to the last maximum reach. When we reach that position, immediately we assign the current maximum reach to the last maximum reach and increment the jump count. So when the last maximum reach is greater than or equal to the last position, then that means we can reach the last position, so we can simply return the currently computed jump count. So in this approach we have to just simply traverse the array once, which is order of n time complexity. Let's look at the flowchart. So input for this procedure is the nums array. First we initialize the current maximum reach and the last maximum reach variable and the jump count and then the count variable, all to 0 except the count will be initialized with the length of the array. First we check whether we processed all the elements. If so, we simply return the current jump count, and if not, we compute the current maximum reachable position from the current positions. Basically we find the maximum of the current maximum reachable, and from this positions how far we can jump. Whichever is maximum we assign that, and then we check whether the current index is equal to the last maximum reach. So whenever we reach the previously computed longest reach, then we have to make another jump. So in this case we have to increment the jump count and assign the current maximum reach, the new recently computed current maximum reach, to the last maximum reach variable. And then we check whether that last maximum reach variable is greater than or equal to the last position of the array. That means we are able to reach the last positions. So in that case we go out and return the jump count. Otherwise we keep processing the next element in the array. So this loop continues until we process all the elements, and finally we return the jump count. Let's move on to coding. First I initialize the jump count to 0. Next I initialize the last maximum reach to 0 and then the current maximum reach to 0. And initialize the count with the length of an array. And first I check the edge case. If the array has only one element, then we simply return the jump count to 0. Otherwise we traverse the input array to find the minimum number of jumps to reach the last element. So in each iteration we compute the current maximum reach with respect to that current position and based on the jump length of that position. So we always update the current max with the maximum of current max with the current index plus the jump length. Next we check whenever the index I reaches the last maximum reach, that means we have to make one new jump. So I increment the jump count and then I updated the current maximum reach. I assign the current maximum reach to the last maximum reach variable. Next I check whether the last maximum reach value is greater than the index of last element. Then I break out of the loop and at the end I return the jump count. It's supposed to be greater than or equal to, so I corrected it. Next I'm going to run the test cases. Okay, all the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input, and the expected output is 2. So first we initialize the jump count to 0, and the last maximum reach is 0, and current maximum is 0, and the count is totally 5 elements, so 5. And then first we check the edge cases. If the count is, if this is a only one element array, then we can simply return the jump count is 0, because we are always positioned at the index 0. Okay, otherwise we start from the index 0, and on each iteration we compute the current maximum reach, which is nothing but the maximum value between the current maximum reach so far computed and the current index plus the jump length of that position. Okay, so when we begin iteration 0, when we enter the loop, jump count is 0, current maximum reach is 0, last maximum reach is 0. Okay, so this picture depicts when we leave, what is the position the index are all pointing to. Okay, so at index 0 the maximum jump length is 2. Okay, so as per this logic, so the current maximum reach will be index 2. So that's what we are seeing here. And then we check whether the current index is equal to the last maximum reach. So last maximum reach is 0, and currently we are at point index 0. So this condition is met. So we increment the jump count. So now the jump count is 1. And then in addition to that, we updated the last maximum reach variable also with the value of current maximum reach. So both are same now, 2 and 2. On iteration 1, when we enter, the jump count is 1, current maximum reach and last maximum reach both are 2. But the index is pointing to index 1. Okay, so here the current maximum reach, when we compute, it will be like the previously computed maximum of 2 comma the index 1 plus this jump length 3, which is 4. So 2 comma 4, whichever is greater, 4. So we are updating the current max to 4. And then we check whether the current index is already reached the last computed maximum reach value. So in this case it is not, because the current index is 1 and the last maximum reach we computed is 2. So we are not executing this piece of code, and we proceed with the next iteration. On iteration 2, when we enter, the jump count is 1 and the current maximum reach is 4, and the last maximum reach is 2, and the current index is now 2. So we compute the current maximum reach from that position. So the current index is 2 plus 1, 3. So the maximum reach is 3, but we already have the longest maximum reach, so 4. So that remains same, 4. And then we check whether the current index is equal to the last maximum reach, which is true. The current index is 2 and the last maximum reach is 2. So we are entering this block. So we increment the jump count to 2 and updated the last maximum reach with the current maximum reach value, so which is 4. So we are updating it, and then we check whether the last maximum reach is greater than or equal to count minus 1. So which is true. We are able to reach from here to all the way there, end of the element and beyond. So we simply break out of the loop, and then we return the jump count, which has 2, and that is what the expected output is. So in this case, how many iterations we do? 1, 2 and 3. Even though the size of the input array is 5, within 3 iteration we are able to find the minimum number of jump count. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. For this input, the input array size is 5. Let's see how many iterations this for loop performs. And so as per the code flow, if you look at in the previous part, we can break out of the loop after 3 iteration. So first we begin with 2. First begin with first index. When we reach the 3rd iteration, at that time we are able to reach the last element. So total number of iterations is 3. This is for the best case, but in case if each one of them have a jump length of 1, in that case we will have to traverse the entire input array. So in that case, the worst case scenario is all are with the jump length 1. In that case, the time complexity will be order of n. So the space complexity is we just use few variables. No additional space is allocated with respect to the input size. So the space complexity is order of 1. Thanks for watching this video. Have a great day.